Hello and welcome. I'm Dr. Pauline Fu. In this lecture, I will present regression analysis as well as simple linear regression. I'm going to do this presentation by analyze an example. So every concept, every formula, I will use this example. And this example is on page 142 of our textbook. So question 3.63. Okay. So I'm going to utilize this data. The question said the editors of the American Academy of Management Journal called for expanding management-related research of African countries by by noting the diversity of countries. They illustrated this diversity by comparing a sample of 10 African countries with China, Germany, and the United States on several variables. The three variables shown in this table are gross domestic product, GDP per capita, a degree of freedom in political rights, measured on a 7-point scale. 1 represents the greatest degree of freedom, 7 the smallest degree, and the level of government corruption measured on 100 points. 0 indicates the highest level of corruption, and 100 indicates the country is free of corruption. So I will explain the concept first, then I will do question 1, A, B, C. Okay. So for this question, we have a variable of interest, country. We also have GDP, political rights, corruption level. We want to explore if corruption level has some connection with GDP. So we call this corruption level is Y dependent variable. And this X, GDP, is an independent variable. Okay. And we also want to explore the relationship between corruption level and the political rights. So this political rights is another variable. Maybe we call this X2. This is X1. Okay. So again, Y is a corruption level, dependent variable. X2, political rights, independent variable. Okay. So you understand this one. And then what is regression analysis? Remember the data given, it is just a sample data. It is just a sample. Because in Africa, based on the United Nations, we have 54 countries in Africa. And only 10 countries are taken. Only these 10 countries are taken as a research subject. So those are the sample data, okay? Of course, the sample data also include, China, Germany, and United States, okay? So anyway, the country listed here are the sample data, okay? So all these countries are sample data. If we want to make a prediction, we want to say, we want to predict the country in, which one is not on this list? Maybe, let me grab a country. So maybe the country not in this list, maybe, let's see, Canada. Canada is not this sample, okay? If we know the GDP in Canada. Can we, based on this model, predict corruption level? That is regression analysis. So regression analysis is to use mathematical model to predict dependent variable y based on given independent variable x. For example, in Canada, we also have our GDP, right? And we want to know the corruption level in Canada. That is the regression analysis, okay? And now, based on this data, always have this data in mind. This data is a sample, okay? So now, oops, try to. Now I'm going to explain some concept based on that example. I already explained what is the dependent variable. Dependent variable is also called response variable. In this example, corruption level is the dependent variable. And independent variable, in this example, the GDP, okay, GDP is an independent variable. This one is corruption level, okay? Corruption level is a dependent variable, okay? Another independent variable is, I want to move this, is political rights, okay? Political rights. So another dependent variable is political rights, okay? So now I will explain what is the probabilistic model. When we are talking about model, usually that is referred to population. The model refers to population, okay? And the EY is the mean value of the population. So in this example here, oops. So remember, all the data here is the sample. So all this number is the sample data. The data is sample data, okay? And this sample data has the average, Y bar. We use Y bar represent sample average. And what is the difference between sample average and the population average? Okay, there is a difference. That difference, we actually use the random error. This guy here, this epsilon is the random error, okay? And based on sample data, we can calculate the sample mean X bar, because this is important, I want to type in, okay? Sample mean X bar. We use sample mean X bar to estimate population mean EY. Okay, use sample mean X bar to estimate population mean EY. So EY is the population mean, okay? And now, what is this Y? This Y is, in this example, it is corruption level, represent corruption level for population. Everything here represents population, okay? And the epsilon is the random error. And we call this one is a probabilistic model, And now we have another terminology, deterministic model. Okay, I'm going to. Deterministic model, it is just EY. For example, EY equal to, just for example, beta 0 plus beta 1 x1 plus beta 2 x2. Something like that. That is the deterministic model. So did you see the difference between deterministic model and probabilistic model? Probabilistic model have this random error, and the deterministic model does not have a random error. Okay, so you could add other items. So that is the difference. So the deterministic model, okay, try to use different color. This part, so this EY, exactly the same as this EY. If you expand this EY, it is a deterministic model. Okay, and also pay attention to the notation of Y bar. Okay, so Y bar, I already explained, it is the sample mean. Y is the original data. Okay, so if you look at all the number here, see, all the number here is the Y. All the number here is the Y. Okay, and then we also have a textbook, have the notation Y hat. So Y hat is the predicted Y. Predicted Y is Y hat. Okay, predicted Y is Y hat. And how do we predict? We need to set up a model. Okay, I will do this model later, but first I will explain this concept. Okay, so we have a Y hat, predicted Y. Okay, and Y hat actually also has an equation. We call that is a prediction equation. Okay, so another terminology I'm going to type in, prediction equation. Prediction equation, we use Y hat. We say Y hat equal to beta 0 hat, this is the constant, and plus beta 1 hat x1, just for example, okay, it could be other format, beta 2 hat x2, etc. So this is a prediction equation, okay, prediction equation. So hope you distinguish between among those different concepts, probabilistic model, it has epsilon, Y equal to EY plus epsilon. And deterministic model does not have epsilon, it's just EY. And the prediction equation is Y hat. Y bar is the sample mean. Okay, sample mean use a Y bar. Okay, so those are the concepts in module 2, regression analysis. Okay. So now in module 3, you are going to set up a simple linear regression. So return back to this example. Okay. So now I'm going to answer question A. Construct a complete simple linear regression analysis to evaluate GDP as a linear predictor of corruption. Okay. we said GDP is an independent variable. Independent variable has another name, predictor. Predictor means independent variable, okay? And Y we also called response variable, okay? So there are different labels. All right, so how I'm going to do this? I'm going to do this in two methods. One, Excel, two, SPSS, okay? So first I'm going to use Excel. So I have data here. This is the Excel data, oops. And we have country, we have a GDP, we have a corruption level. Question A asks you to set up linear relationship between GDP and corruption. What is the linear model between these two variables? Remember, GDP is X, corruption level is Y. Okay, so to do this using Excel, you go to data and then data analysis. If you do not have data analysis on your Excel, you go to File, Options, File, Options, Quick Add-ins, and then check Data Analysis Toolpack, and then click Go button. After that, you click OK button, so that you are going to have the data analysis here. Okay. So we are going to do regression analysis. So I click OK button. I will delete everything here, re-enter. Input Y range, see, this is my Y from J1 to J14. Input X, C1 to C14 is my X. The first row contains labels, so check out the label. Output range, I want to put output in L2. So you click L2. You can click anywhere, and you can select new worksheet, okay? And then I click OK button. So, and this table is extremely important. We are going to use this table throughout the semester, throughout this course, okay? So in this table, you have linear correlation coefficient R. So this is linear correlation coefficient. Okay. Also called multiple R. This number is 0.89. Okay. This number, if this number closer to 1 means the stronger relationship. If this number is a positive, it is positive relationship. If this number is negative, negative relationship. Okay. And this is R squared. We saw coefficient of determination. Okay. Another name for R squared. Adjusted R squared, it is adjusted for other factors such as sample size. Okay. And standard error, it is the equivalent of standard deviation for regular data. Remember, if I give you any data, I ask you to calculate standard deviation, that is the equivalent of that one. So standard error is standard error for regression. We hope the smaller the standard error, the better the model. Okay. Observations, we have 13 observations. So this is 13 data. The first row is label. Okay. And now we have this ANOVA table. Again, very important. Make sure you know the relationship among these tables. during the quiz or test, I will delete some numbers on purpose, and I'll ask you to fill out the numbers, okay? So basically, maybe I want to copy this one so that I can do analysis on one note. I can write down the note, okay? Try to adjust my computer. Right. All right. So now, so this SS means the sum of square due to regression. This number here, sum of square due to regression. Okay, this number. Try to use the color. I cannot write. Okay, so this number here, SS, represents sum of squares. Okay, try to make a notation here. Okay, here we go. Okay, and this number is the sum of square due to error. So this one we actually use SSR, and 811. This is SSE. Sum of square due to error. Okay, maybe I'll write on the side. So for SS, I will write down something on the side. 3,345, that is the sum of square due to regression. 811 is the sum of square due to error. Okay, and then we have MS represent mean square. The number 3,345 is mean square due to regression, MSR. Next, number 73, mean square due to error. And then we have F test statistic. F equal to MSR over MSE. So if you use 3,345 divide 73, you get it 45. Okay. And what is the relationship between SS and MS? Okay, there's a sum. Okay, I'm just adjust my computer. The relationship between SS and MS is that MSR equal to SSR divided by degree of freedom for regression. In this case, degree of freedom for regression. Okay, so if you use 3,345 divide 1, you get 3,345. And MSE, mean square due to error, equal to sum of square due to error, SSE, divide this degree of freedom for error. Okay, ERROR error. So if you use 811 divided by 11, you get 73. Okay, so this is the ANOVA table. Okay, and over the last table, you are given the beta 0 and beta 1. So this intersect, if you took CQMS202, it is this one is B0, and this one is B1. One is intersect, the other is the slope. Now, our textbook use different notation. They call 25.8850 is beta 0 hat is actually intersect. And they call 0.0098 is beta 1 hat. It is the same as one is B0, the other is B1. Different label, but exactly the same meaning. Okay. So that is this model. Okay. So I got the model. And also you get the significance level. This is the p-value. The p-value is here. Remember the universal rule for p-value. When p-value smaller than 0.05, you reject H0. You have to understand it reject H0, not H1. And if p-value greater than 0.05, do not reject H0. Okay, do not reject H0. That is the p-value method. Okay, so return back to our question here. What is the question here? The question asks you, construct a complete simple linear regression analysis. I already did analysis. I analyzed that table, okay? And now we have to write down a prediction equation here. So what is the, prediction equation here, prediction equation. Because use prediction equation, I can make prediction, okay? So I can write based on this result, okay? So the prediction equation is y hat equal to beta 0 hat plus beta 1 hat x. That is the prediction equation. Okay. And now you can write down what is y. Y represents corruption level. So you can use the word, okay, you can say corruption level equal to beta 0 is 25.8857, okay, plus beta 1 hat 0.00098, then x. What is x? X is GDP, okay, and there is a time here, times GDP. So that is the regression model, linear regression model, okay, or prediction equation. But sometimes when you set the model usually has the error term, epsilon. Okay, I have no way to type in epsilon. So I'm just going to type random error. Okay, so if you have plus random error, that is the regression model. Without random error, that is the prediction equation. Okay, so I And then how do we know this model is significant? You check out p-value. Here p-value is 3.2. 3.2, e negative 5 means times 10 raised to power negative 5. So this is a very small number. So p equal to negative 5 means move this decimal to left 5 times. Okay. So this is p-value. Obviously, this p-value is smaller than 0.05. Usually we use 0.05. Okay. Because it's smaller than 0.05, we reject H0. But what is my H0? H0 said the slope, okay, beta 1 equal to 0. H1 said, H1, our textbook also use HA, the same as H1, okay? Beta 0 not equal to 0. And now we reject H0 because p-value is smaller than alpha. This one usually is alpha. We reject H0. Therefore, we conclude the slope is not 0. Slope is not 0 means there is a relationship between corruption and GDP. Okay, corruption and GDP. So that is our conclusion using the Excel. Now I'm going to use SPSS. Okay. So this is my, so I'm going to start all over again so that you know where I started. So you can get SPSS Google Ryerson Virtual Lab and then use your Ryerson credential. Okay. So I'm going to maybe delete all of this data because I want to show you how to get the data from scratch. So I'm going to open new data. Or you can import data if you have data on Excel. Okay, so I'm going to, it is actually my CSV data. So I saved data in C drive. Under my name, I have this 442 data. So this is African data. So Africa, this is the data. Okay, I posted this data set on D2L under course material. It is zip file. You need to unzip it. So first line contain variable names. Okay, so I just click OK. So this is the data I just get. Okay, so now how do I use SPSS? You want to explore the relationship between GDP and the corruption level. So you go to Analyze, Regression, and then Linear. Dependent variable, corruption. Corruption, you click corruption, click this arrow key, is the dependent variable. Independent variable is this GPA. Okay, you click it. Okay. Sometimes you are also asked to get prediction interval. You go here, you click Save button, and then prediction interval for mean or for individual. You get prediction interval. That is the question when you did CQMS 202. Okay, you check out those. Then you click OK button. After that, you just click OK button. And you see you get similar results from Excel. You get this sum of squares, mean square F. And you get this 25 constant. the slope 0.001. You get exactly the same thing as you get from Excel. Okay, so that is the, I'm going to maybe just copy this as a reference to my OneNote. Okay. So that is the SPSS method. All right. So I did example about complete simple linear regression analysis to evaluate GDP as a linear predictor of corruption. Question B asks you to complete a linear regression to evaluate political rights is X, corruption level is Y. You do exactly similar stuff, okay? You just repeat yourself. So I'm going to do Excel method and then do the SPSS method for what? For explore the relationship between political right here, political right, and corruption level. Okay, so go to data analysis, regression, click OK. Y is still the same. X, you choose different X from H1 to H14 is X. Output range, this time I'm going to put maybe here is my output. That's it, okay? So from here, you can write down the regression equation based just on these two numbers. Based on these two numbers, you can write down regression equation, okay? And over here, you can get the p-value. This is p-value, okay? Obviously, p-value is smaller than 0.05, okay? So again, I'm going to copy this into OneNote. And this is question 2. Where is my OneNote? Is here. Okay, and based on this one, you can write down the equation. Y hat equal to, okay, Y hat equal to, maybe I'll write. So I'm going to maybe just write down corruption is Y equal to 66.0641 minus 6.247. That is the political right. So this is the equation, okay? You can use mathematical symbol. Y hat equal to 66.06 minus 6.247 X. To distinguish, maybe you write down subscript, means this is political right. Once you have this equation, you can make prediction. When x2 equal to a value you plug in, you can predict y when given x value. Okay. All right. And in your textbook, I'm going to show you. Yeah, the summary part, you have page 152 is the summary of module 3. Okay, is the summary of module 3. So take a look at this one. So this is our hypothesized model. Okay. And then we have data. This is another one. It is just that part. So anyway, this page gives you a summary of create a simple linear regression model. And I use specific example to illustrate the process, okay? Hope this video helped you understand the basic concept and techniques involved in simple linear regression. Thanks for watching.